Hello, this is Elizabeth. Here's Engineering Economics video number 14. And today this is a short video on equal uniform annual cost, otherwise known as EUAC, and equal uniform annual benefit calculations. That one is known as EUAB for benefit. So what we want to do in an EUAC or EUAB calculation is to turn any series of cash flows into an annuity. So basically, you're going to be finding A for any set of cash flows. They can be cash inflows, cash coming in. Turn that series of cash flow inflows into an annuity, find A, or for cash outflows. Same exact procedure, it doesn't make any difference at all. So what we have here in this little timeline, a cash flow diagram, there's a future cash flow out here at time n in the future, and we want to take that future amount of cash flow and turn it into its equivalent annuity, or like basically annualizing or averaging that future cash flow. If it were instead to be spread over several years cash flow, what would be that A? What would be that amount? So find A given F. Similarly, we can do the same thing where we're given a present cash flow and we want to turn it into its equivalent, equal annuity amounts, as if that present cash flow were to happen over time in the future in equal annual amounts. Then what would that amount be? That's what we're looking for. So that would be find A given P, right? And on these both of these two cash flows diagrams, I've drawn them as inflows, but it works exactly the same for cash outflows. Find A given F, find A given P. The inflows or the outflows, same procedure, doesn't matter. Okay, so what EUAC is, equal uniform annual cost, is summarize the annuities that are outflows. That would be the cost, the costs. Equal uniform annual benefit is to summarize the annuities that are cash inflows or benefits. And basically then, here's our decision rule. We divide the benefits divided by the cost. So EUAB, that annuity amount, that is the annual amount of the benefits, divided by the annuity amount of the cost. And that is, those are both in terms of A, but the numerator is the benefits and the denominator is the cost. We want that to be greater than 1.0. If it is, then accept the project because the benefits are greater than the costs. All right, let's do an example. Just real simple, the initial cost of a particular machine that we might buy is $80,000. The future salvage value, what we can sell that machine for, estimated amount, what we can sell that machine for in the future is $20,000. Annual operating costs of running that machine is $18,000. So that's let's just note something, that's an annual cost that's happening the same amount, $18,000 over several years. And so that already is in terms of A, right? So we don't need to do anything with it. In this example, I think we're going to say our interest rate is 10% and our N is 20 years. Okay, so let's find the equal annual benefits and equal annual costs of that series of cash flows. Before we get into the calculations, I just want to show you this time diagram, cash flow diagram that I've drawn. Initial purchase cost in our case is $80,000 going out. The annual operating cost can be either, well, annual operating costs would be cash outflows, right? Would be down arrows. If we had cash inflows from production, those would be cash inflows, so up arrows. And we'd estimate what they were per year. And then the salvage value at the end is a future value, and that's its estimated selling price or resale price at the end of the machine's term. That would be a cash inflow. And then disposal costs are cash outflows. That would be cleaning up a hazardous waste site or any cleanup and shutdown costs that have to be incurred at the end of a project or end of a machine's life, taking it down and disposing of everything properly. So what we want to do is take all these cash flows basically and find A, right? Find A for the benefits or the cash inflows, and then find A for the costs or the cash outflows. All right, let's get back to an example here and actually solve it. The example I gave on the prior page, we had $80,000 cost, and what we want to do is turn that into an annuity. So we multiply the cost, which is in terms of P, right? And then we multiply it by a factor, find A given P, 10%, 20 years. Then salvage value, that's a future value. So we have so we put the $20,000, multiply it by a factor, find A given F, future value, 10% for 20 years. And then the $18,000 operating costs. They already are in terms of A, so we don't need to multiply that by any factor at all from the interest table. Let's take a look at the signs that I've used here. I have used cost to be like the positive. So if I said $80,000 was the initial cost, then I would also use a plus for 18,000 operating costs. And then just the opposite sign, I would subtract out anything that is income or cash flow in, and that our salvage value is cash flow in the future when we sell this. So I would subtract that set of cash flows. It doesn't matter which way you go, you can have the costs be negatives and the inflows or benefits be positives if you want to, just as long as you're consistent. Here I have the costs as positive numbers. So just finding the factors from the interest table, 80,000 times that factor from the AP column, 10% interest table, line 20. And similar with the other, we've done this before. And then we get that down, just do the math, and we get to 27,050. So I know that my positives were costs, so that is a positive number, and that's our annualized or average cost per year for running that machine. So we can say the equal uniform annual cost of that particular machine is 27,050, and then decide if that's acceptable or not. All right, so just a little summary here. Again, a cash flow diagram, a timeline, and everything that's up arrows on this cash flow diagram is the benefits, right? And everything below the cash flow diagram, arrows going down, are the costs. And we want to find A for any present value or any future value. And then do the division here, sum up the benefits, sum up the benefits when they're all in terms of A, then sum up the costs all in terms of A, divide them, and you want your answer to be greater than 1. If it is, then that means an acceptable project. If it's less than 1, just a little bit less than 1, you can use like 0.98, 0.97. You would have to use qualitative factors, any other factors that are relevant, not necessarily the cash flows, because we've already accounted for that, but what other factors would be relevant in making that decision? Safety, do we need it to stay competitive? Our employees want it, you know, other qualitative factors like that, that would help make the decision when it's real close to 1. One other thing here I just want to note, here we divided, here we divided benefits over cost in terms of annuities. We can also subtract them. So if we took the benefits minus the costs, then we'd have a net benefit or net cost, and that's just another analysis tool. If it's a positive, of course, that means definitely accept the project. If the benefits are greater than the cost, when you net them, to subtract them. Okay, so now you know how to solve for EUAC and EUAB. Thank you. The end.